Hello guys, this project is about deploying the Neo4j database on AWS. So Neo4j is basically a graph database that is used for faster processing of queries. So if there are a lot of complicated queries, Neo4j has a graph-based structure in which there are multiple nodes and they are used to process complex queries faster. So it has certain set of dependencies that must be met to work efficiently. So for this purpose, I have used AWS Cloudformation, which helps in providing infrastructure resources as code in YAML or JSON templates. So let's look at how they are formed. So there are a various number of stacks that can be created in CloudFormation. So each stack has a certain pile of resources that is run together. So this stack name is Neo4j for RFPs. Over here, you can see that there is a stack info, parent stack, when it was created, etc. These are the events, like while creating, what kind of logical IDs were run, and these are the resources that were required. Like there is an Elastic IP, EC2 instance, Internet Gateway, security groups, a VPC. So these are all the different things, and this is the output basically. So output is where the stack provides certain URLs in which you can click and your database will be up and running. So let's look at how the stack is created. So over here we will just choose existing template. So here I have already made the stack and updated all these information previously. So there will be a password for accessing the database and the infrastructure configuration. Now, why do we need an instance for using Neo4j? We need a virtual machine to run the database. Otherwise, we won't be able to access it. And since we are deploying it on cloud, the instance is provided by AWS. So the type of EC2 instance that we are using is T3 medium. Now, this is the minimum requirement of the instance for Neo4j to run. So basically, there are certain instances which are less powerful than T3 version, but Neo4j doesn't work on them. So over here, T stands for the class of instances. This 3 is the generation of instance, and anything that follows after this dot is the size of the instance. So this is a medium size instance. Then we have large, extra large, and so on. Now the disk size which we want on the elastic block storage is 100 GBs. Now this is provided in the documentation that a minimum of 100 GB is required for processing of queries fast. Basically that is the whole purpose of the Neo4j database. And this specifies that we can access this from any IP address. There is no restrictions on it. Next, we have that do you want to have an identity and access management role? But over here, I don't want to have it. And failure options, we will set them as default. And currently, I have already provided the YAML file, so there is no need for any changes over here. As you can see, there was an error creating this change because the information didn't contain any changes. So we need to provide a different template. So that is how stacks are created. Now let's look at the EC2 instance T3 medium which is being run. So EC2 stands for Elastic Compute Cloud, and that is why its name is EC2 because C comes twice. So this is the EC2 dashboard. Currently, I'm not running any instance because the T3 medium instance doesn't come under the free tier of AWS. Free tier of AWS provides free instances up to T3 micro, I guess, and we are using T3 medium. So running instances is zero, but we have a stopped instance. As you can see, Neo4j. Over here, we have all the information about the instance that is required. Now, this is the public IP address of the instance. Over here, I would like to say that every time you stop the instance and start it again, the IP address of the instance changes, as AWS can't afford to just set a single IP address for your instance when it is starting or stopping. But if you want to exclusively have a same IP address, you can create it using elastic IPs over here. So as you can see, I have one elastic IP, and you can see the allocated IP address is 13.202.67 and 121, which is exactly this over here. So what happens is, to prevent extra cost from occurring, I have stopped the EC2 instance and allocated an elastic IP, so that whenever I restart the instance, the IP is not changed and the stack works perfectly fine. Another thing is, over here we have security details. Now, inbound rules and outbound rules. So what are basically, security group is like a firewall that allows access to the instance and what kind of resources the instance is able to access. So the inbound rule is from what ports the request can come to the instance. So by default, the Neo4j runs on 7474, and 22 is the port of our instance. Outbound is basically our instance can access everything which is outside. So as you can see over here, there is a volume attached which is 100 GB in size, as we had seen in the Cloudformation when we were creating a stack for Cloudformation. We provided the volume of 100 GB. So it is attached in this directory of the Linux instance, and it has its key ID. And when we delete the instance, the volume will be deleted itself. So this is yes by default. Now let's look at the YAML file. Over here we can see that this template version is from 2010, and we have the metadata information provided over here. Now the parameters, password, these all is same. Now the instance type that is allowed for Neo4j is basically T from T3 medium to R6i extra large, 32 extra large, and by default it's T3 medium. So disk size, you can see type number default is 100 GB and minimum value is also 100 GB. And okay, what kind of resources are required? So by default, AWS gives you a single VPC, which is a virtual private cloud, but Neo4j requires a separate VCP for it to function. So over here, a separate VPC is created, and the CIDR block is this, means that the VPC can have any IP from 10.0.00 to 10.0.255.255. So this is the Neo4j subnet, and we have the route table, routes. Okay, so this is the security group. So over here you can see that we have enabled SSH and external ports for communication. So this inbound port is 22. 7474 is also an inbound port. All these are inbound ports. Means external services can access these ports of the instance. That is what is meant by inbound rules. Now, this is the Neo4j EC2 instance. This is the information about that. Now, we also have provided a volume. So this is where the volume is attached. As you can see, EBS. Volume type is GP3, which is general purpose, and this is the user data. So user data is basically the bash script which is run when the instance is created. So when the T3 medium instance is created, by default this bash script is run. So this is all about the YAML file, which in which we are providing the infrastructure that we required in the format of a code. So this can also be in the form of JSON, but we don't have to manually create this cloud formation. We just have to select option, and it gives you the ready-made template. After that you have to select whichever type of resources you want, and also edit some things if you want to add certain things or remove certain things from this. So now let's look at how this thing functions. As you can see, the instance state is stopped, but we will run this instance first. Now this will take us few time to start. Yeah, so now it's up and running. The status check is still left, but we'll wait for that. Yeah, so as you can see, I'm connected to the Neo4j database, and over here I can function, I can create database and work with queries and other things. Now, what if I stop the EC2 instance? So basically, this is the IP of my machine and port where the Neo4j database is running. If I stop the instance, I won't be able to access the Neo4j database. As you can see over here, the instance is stopped, and if I reload this, see now already it's telling me the server is taking a long time to respond. If I reload this, the Neo4j database won't be available, and if we stop the instance, we also won't be charged for the uh, time the instance is running. So basically, it charges $0.05 per hour. Now you can see it can't reach this page. So in this way, you can control the functioning of instances and the databases you want. So this was all about the project. Now, why did we use Cloudformation is because it helps in automated resource provisioning. And as you saw that an entire pool of resources is required to maintain a stack. So this stack itself has certain set of resources which are dependent on each other. If we manually go to do this, we need to keep in mind what are the dependencies of certain resources. Like an EC2 instance should only be created after the necessary VPC and security groups are set up. So I may directly create an EC2 instance before setting up a VPC, and in this way I can disrupt the working of my stack. So this was all about the deployment part. I hope you like it. Thank you.